Hello, everyone. This event is brought to you by Data Talks Club, which is a community of people who love talking about data. And this is a weekly event. We have two weekly events. Today, on Tuesday, we usually have webinars, more technical events with a presentation. And then on Fridays, we have interviews, live interviews. To find out more about our events, you can go to our website. The link is in the description. So you can just click on this and see what are the events we have planned. And something I wanted to also mention is that we plan a conference. So there will be a conference in June. You can go there on our website and see what we prepared. So there will be 2 tracks, career in data and machine learning production. So you can go and check and register there. And one thing you can also do is subscribe to our Google Calendar. So many people said it's very useful. You can just subscribe to our calendar and you will get notified about all our events. So then, of course, to stay up to date with what's going on our YouTube channel, you can subscribe to our YouTube channel and join our Slack to talk about things, data-related things. During today's presentation, you can ask any question you want. There is a pinned link in the live chat. So you just click on this link, you ask any question, and then at the end, we will cover these questions. And yes, I think that's all. So the floor is yours.
Okay, perfect. So I'm gonna start by sharing my screen. Can you see it?
Yes.
Okay, perfect. Perfect. Let's go. So I'm very happy to be here tonight. I'm Nastasia. I'm from France. And today I wanted to talk about what I've learned so far about productionizing ML systems without their or heroism. At least this is our goal, my goal. Yes, so you can follow me on Twitter with @Saby Nastasia. And just to introduce myself a bit. So I'm a machine learning engineer. I'm focused on productionizing ML systems. And I am very interested in this topic. This is why I have also a blog, which is named ML in Real Life. And I have also decided to self-publish a book in French to speak about the things I've learned. So if you're interested and if you speak French, you can get it through the LeanPub platform. I used to be a backend software developer, and now I am a machine learning engineer. I have worked on different ML systems. Here are some examples, such as predicted breakdowns, being able to do anomalies detection. I have also worked on sales models. It was most of the time supervised learning or unsupervised learning, and shallow learning most of the time. So it means that no real deep learning so far. Okay, so here is what I propose you. I propose to look at best practices that you can find in software engineering and see how we can apply them in our field. So as I said, I used to be a backend software engineer. So naturally, my first move was to look at what we can find is in this field to apply them in our field and to see how we can also adapt them. Then I will do a focus on 3 things: data versioning, unit test for data, and data monitoring. So at the end of the day, we'll do a focus on data. Okay, so first of all, looking at best practices in software engineering. I think definitively that predictive systems have a lot to learn from traditional programming. Why am I saying that? I am saying that because predictive systems are a quite new field, which is not the case for traditional programming. Of course, it is quite new, but predictive systems are more fresh and newer. So maybe we can look at what traditional programmers are doing to see if we can find best practices that can help us. And in the end, if we look at these practices, uh, you can see that they try to achieve the same goal, which is deliver something properly, being sure that everything is okay when there's a new release, being sure that everything is okay during the life of the application, and they also try to be able to time travel when something wrong happens. So they try to reproduce bugs, to reproduce a behavior. And finally, we want the same thing. Uh, we also want to reproduce a weird prediction, a weird behavior. We want to check that everything is okay when we deliver something, and we want to check that everything is okay when we release something new. And to do that, what do? They test version and monitor the code. And finally, we also have code. So we can do the same. We can test, version, and monitor our code. And I think it's a good start, but I think it's not enough because predictive systems are different from traditional programming. Why? Because if we look at traditional programming, this is the overall picture. We have data, we control this data, and with this data, we build a program. I mean, we build a program that generates data. We can control this data. We also control the program because we build it. We know what is inside. That's true that sometimes we can use other libraries, but we have the ability to know what is inside the program. And with that, we want to achieve results. These results are functionalities that an end user can activate or not. Yes, so this is quite different if we look at what predictive systems are, because we also have data, that's true, but we don't control this data most of the time. We have to deal with that. We don't choose this data. And we want to achieve a result, which is to replace a cognitive process. So it's not a bunch of functionalities. No, it's a bit different. We want to achieve only one thing. And with this data and this result, we build a program. And we don't control all the program. It's the same because a part of the program is the model. That means that a part of the program is stochastic. And another part of the program is driven by data. So at the end of the day, it's different. And we can say that data and models are at least as important as the code in data science. And I think personally that they are maybe more important. It means that, yes, it's interesting to test version and monitor our code, like traditional programmers are used to do that. But maybe we have to go beyond, to go a step further by testing not only the code but also the data and the models. And same for versioning. The idea is to version, monitor, test code, data, and models. And with that, the goal is to use these best practices, to adapt these best practices to our field, to constantly add value and be able to maintain a regular pace. With this idea, we answer to a principle of the Agile Software Development Manifesto, which is sustainable development, able to maintain a constant pace. And it's also a way to answer the software craftsmanship manifesto, which has a value which is not only responded to change, but also steadily adding value. Then as a recap, this idea of adding value constantly at a regular pace. And also another thing that we want to achieve with looking at these best practices, apply them, adapt them, is also what we name reproducibility, and that is very important in our field. It's like a diamond, the holy grail, and we all want to achieve that, and it's not always easy, but I think that with testing, monitoring, and versioning code, data, and models, we can achieve that. And finally, the overall idea is to be able to develop without fear or heroism, peacefully. This is at least what I try to achieve, and this is what I want to present you in this presentation, what I have learned to reach this goal, or to be closer this goal. So as a recap, our goals is to add value at a sustainable pace, and the goal is to be able to reproduce a bug or a past prediction. And I want to achieve that with serenity, without fear, and without heroism. It means that we don't want to be heroic, and we don't want to be fearful. We have to do that, to do the things quietly. And my proposal to do that, as a recap, is to look at best practices from traditional programming. But of course, we have to go a step further, because we have to take into account the specificities of ML systems. It's not enough just using the best practices from software engineering. We also have to adapt them to our current field. Okay, so it was my introduction, my goal, my proposal. Now I would like to present to you different ways of achieving that. So I'm gonna start with an example, which is versioning data. So why should you version your data? As we have already said, data is more important, or at least as important as the code. This is why at the end, if we version the code, why not versioning the data? And my experience showed me that if you want to time travel, it's better to have data that is versioned, because you can time travel for your code and for your data at the same time and see what happened. We have different ways to version data. So first of all, what we can do is doing it ourselves. So, for instance, you can decide to tidy your data in different folders. For instance, if you receive new data each month, you can decide to get this data in different folders. For instance, the folder month 11 will correspond to the month November, month 12 to the month December, and you will have only the data that corresponds to this month. And in these different folders, you can save states, the state of the data, or events. If you save states, it means that you can only load the data of month 11, for instance, and you will have the data at this month. You don't have to do anything else. So that's not so bad. The disadvantage is that that means that you save all your data each time, the state of your data, and it can grow and grow, and it can be difficult to store all of that in your cluster. You have also the ability to save only events. So, for instance, you receive some events on the month 11 and you decide to only store that. So it can be better because you have less data, but you also have to build the state each time you want to access the state of your data. So you can do that yourself. If you do that yourself, of course, it means that you have to develop that, debug that, maintain that. So it can be difficult, but it's doable. And you can also decide to choose a tool. Now we have different tools to version data. So I'm not here to promote any tool. I will just show you the tools I know, in this case, Delta Lake, but you can use the tool you want. I'm not sure Delta Lake is the best in this case, but it works. And then you can use Delta Lake. And Delta Lake, it's a software which is upon your data lake, and it will version your data automatically. So that means that you don't have to think of versioning your data. In this example, for instance, I have two versions of the same data. I can time travel, decide to load a previous version, etc. And just to say that Delta Lake uses the events, the concept of events, to store the different versions. So I think it is nice to get an automatic tool and an open source tool, because you have all the community behind you to debug your tool. But it can also be sometimes difficult. Recently, I had a bug with Delta Lake, and it was difficult to find a workaround. I finally found a workaround thanks to someone from Databricks, but it was not easy. And if it is your own code, I think it can be easier in this case to debug it yourself. I just would like to present you a demo of that. A quick demo. So here I am on the Databricks platform in a notebook. I'm not saying that notebooks are perfect for production, but it's a way that is very easy to present things. So this is what I'm gonna do. So first of all, I'm gonna import.
Sorry for interrupting you. May
Yes.
you enlarge the font a bit?
Yes, of course.
Okay. Easier to see. Okay. Oh, it's
Is it
already.
better?
It was already. Yes, it is better. Thank you.
Okay, no problem. Okay, so I'm gonna use Spark to access Delta Lake, but you can access Delta Lake another way. I don't know how to do that, but I know that it's doable. So first of all, I'm gonna just load a file saying that the format is Delta, and just show it. I'm saying that I want to load the data with the format Delta, but Delta is not a format in reality. It is just a software. But in this case, I have to say I want to read the data in the Delta format. So here we have some information about employees with their first name, middle name, last name, ID, gender, salary, anyway. And what I want to do, first of all, is to see the history of this data. So I can use the function history upon my file thanks to Delta. And then I have the two versions. I have different informations about these two versions. I have the timestamp, the user ID, the username who did the modification, which kind of modification was done, how the modification was done, the notebook, the cluster IDs. So you have many information. To say the truth, most of the time I only look at the maybe 1, 2, 3, 4, 5 columns. That's all. And what I do a lot is time travel. And to do that, I can decide to time travel using the option version as of. It will load the first version, which has the number 0. And if I don't say anything, I'm gonna load the last version. So maybe we can compare the two. Here, Maria Anne at the beginning, so the first version, became Elliot Anne. Same for Robert, that became Elsa, etc. So we have a way to time travel through this data. And I can also time travel through the timestamp as of version, just saying that I want to see the state of the version of the data at this timestamp. Okay, so in my case, it's very helpful to be able to reproduce a bug, a past prediction, something weird that happened, but it's not enough. I think because to do that, I also use model versioning and also code versioning to understand what happened. And with that, at least, I'm not saying that everything is okay for me or the world is perfect, but at least it is a safer world for me to develop. Now, the second point I would like to show is data testing and what we name unit test for data, because the data will change. And if we want to be sure that the data doesn't change in a way that we are not able to adapt, I think it's better to have unit tests. I did that especially for one project because we were receiving a lot of data with a lot of bugs and it was difficult to adapt. So we wanted to check that everything was okay at the beginning. So I think it's very valuable in most projects. Sometimes you have the chance that someone else, another team is already doing that for you. But it was not always my case. This is why I decided to do unit tests for data. Again, I'm gonna present you some tools, but I'm not here to promote any tool. I have just used PyDQ and Great Expectations, and I think that these tools can be helpful. So again, I'm gonna show you a quick demo of Great Expectations this time. Okay. So first of all, I'm gonna install Great Expectations and do some imports. I have a data set, which is the Titanic datasets. I'm gonna display it. So the Titanic dataset, I think it is quite, it is well known, but just as a recap, it's a dataset about about the passengers who were in the trip, during the trip, their gender, their name, their class, and who survived. But the idea in our case is that we imagine that the Titanic is still okay, and that we will have other trips, and we will receive other data sets about these passengers. And before using this data set to do some statistic, to do some machine learning anyway, we want to check that everything is okay with the data set we receive. So we can look at the data set we know. We have different information, and we can see that in the embarked column, for instance, we have different kinds of value. We have some null values, and then we have also three letters, which are S, C, and Q. And we want to be sure that every time we receive some data for the other trips of the Titanic, we receive these three letters. So we can do that with Great Expectations. Then I'm gonna say to Great Expectation, use my data frame as a Great Expectation data frame. And now I can apply to this data frame some expectation. Finally, an expectation is a unit test. So I'm gonna say that I want the column embarked with only three values, which are S, Q, and C. Oh. Let's see the result. We have a JSON file, JSON object, where we can see the observed value. We can also see that Great Expectations was not able to do the expectation for two values, which in reality are two null values. And here we have something that is interesting. We have the key success, and we can see the value in front of this key, which is true. So if we want to realize a real unit test that will raise an exception, we can also do that. Just using an assert upon this success key. So in this case, there's no exception. But if I say I want S, Q, and D, this time I have an exception. And maybe we can just look at the JSON object. We have the observed value, and we can see that it is not the same. So with good expectations, you have a lot of expectations to do these kinds of unit tests. And you also have the ability to add your expectations. I have never done that, but I know that it's doable. In reality, what I did at least is applying different strategies to deal with this bad data. Once you have noticed that you have a piece of data that is not good, you can do several things. First of all, you can decide to stop everything because it's too critical. But you can also decide to stop everything if you receive a percentage of data that are not like expected. This is what we did most of the time. It also depends on the kind of errors. If you receive something that is totally wrong, of course you will stop, but it depends. And this helped me at least to reach a step further this serenity to develop without fear or heroism. So we have seen data versioning, data testing, and now I would like to talk about data monitoring. Because it's not always enough to check that your structure is good, your columns are as expected. Sometimes you want to go further to check that your two distributions, the first one with you did your training, and the new one with who you are doing your prediction are close, that you can finally use your model. And why should you monitor your data in this case? Because of two concepts that are linked. The first one is model drift. This is the fact that a model most of the time will see its performance decay over the time. Sometimes it can be abrupt, and most of the time it is due to data drift. That's true that it can be due to a bug in the code, an IP parameter that has changed, but very often it is due to data drift. And just a small example that unfortunately we all know, it's the pandemic that has killed a lot of ML models. So it's a reality, model drift is a reality, and it can be abrupt, because in this case it was very abrupt because suddenly we changed our behavior. The economy was totally different. So for some projects, it could have been difficult to adapt. It depends on your models, of course, but I'm thinking of sales models, for instance. It could have been difficult. How can you protect yourself from model and data drift? There are different things to do. First of all, and we all do that, retraining. We train to get a fresh model. If we don't retrain, over the time, the performance of the model decays. But with retraining, we are able to get refreshed models. But it's not enough. Because sometimes you have to add a feature, remove a feature. It can be something else to do than retraining. So that means that you have to monitor your retraining and monitor your impact in real life, because it's not because your model is good offline that it is good online. Sometimes you are not reaching the goal of the business, but your model is good. So it's good to monitor real life to see if there's a change, something like that. And the idea, of course, is also to monitor the data itself. So to check how the two distributions are evolving. So there are different ways to do that. You can do statistical distances, you can do statistical tests. What I have seen so far is that it's still an open field in the research area. It means that there are different ways to achieve this goal, and it can depend on your context too. I will not present you a demo to do data monitoring because, to say the truth, I'm not satisfied with what I have seen, tested so far about this topic. But I'm gonna show you what I have tested and what at the end I'm finally doing to be able to reach this serenity. So first of all, I decided to do all by myself. It was, I think, a terrible mistake because it was hard. I learned a lot. That's true that I learned a lot, but it was difficult. Then, after that, I decided to test Azure Data Drift. And I think it's a great tool because you have a lot of graphs showing your data evolving. You also can have alerts. That's very good. But the problem is that at this moment, at least it was not open source, and I don't think it's open source now. And I have also a limitation, is that with Azure Data Drift, you can only monitor 200 features. And for one of my model, it was not enough, and it was a model that was very important. So finally, I decided not to use that. Then I discovered Alibi Detect. Alibi Detect is a library that is developed by Seldon Core. And by doing statistical tests, you can see if your distribution is drifting. And it works. I have tested that. It was quite nice. The problem is that once you have seen that you have a detection, you have a drift, so you have detected a drift, you are alone. I mean, the library is good for what it is doing, but then you need some graphs to understand why your data is drifting. I have not really tested evidently AI exactly because it was phasing because of the volume of the data. So I decided to stop because as you can see, I have tested a lot of things, and I think it would be worthwhile to test other things. But for now, I decided to stop that and to find another way, the serenity I was looking for. It was difficult because what I found is that statistical tests are a bit black boxes. Data drift techniques are diverse. I hope they will be popularized soon. I hope that. So what I decided to do is to use mostly unit test for data and model drift detection. So for model drift detection, I have offline model drift detection, and also I monitor real life. So finally, I will show you a demo, but not about data monitoring, but more about a way to version your model to be able to then check that everything is okay during the retraining. So this is my last demo, and I'm going to present you a tool. Okay. Not this one. This one. Okay. I would like to present you MLflow, which is also developed by Databricks, but which is open source. And it's a way to version your model. So for instance, here I have different versions of the models, different retraining with the parameters I used to do these retrainings, and also the metrics, then the accuracy. With that, I can build a lot of dashboards, send alerts, thanks to the API of MLflow. I can see a lot of things, see how my model is evolving during the retraining, and it can give me a lot of information. So how to do that? Okay. Yes. First of all, I'm gonna install MLflow. Okay. Then I'm gonna retrain a model. We don't mind about the model. But once I have the model, what I want is to save this model as an experiment of MLflow. So first of all, I'm gonna say I want to set an experiment, and I give this path to set this experiment. Then I'm able to log metric. So in this case, accuracy. You can see that it is hard-coded, but normally the idea is to take this information from your model. The same for log param. But it also can show you that you can log all the things you want to log about your models, and it gives you a lot of information about your model. And you can save your model itself. And by launching that, okay, we'll see that we have a new model, which is this one. And we can go inside, see the parameters, the metrics. We can also have tags. We have the models, which is here. So we have many information about that. So finally, what I did to do that is using offline model drift, real-life monitoring to see the business impact, and unit test for data to monitor model drift, which is my goal. As a recap, my idea was to show you how we can use best practices from software engineering to do different things, versioning, test. So we saw different examples like data versioning, unit test for data, and model drift monitoring. Thank you very much.
Yeah, thanks. It was quite a lot of demos, so thanks a lot. I think it was very useful. Yeah, we have a couple of questions, and I want to remind, if you want to ask any question, there is a pinned link in live chat, so you can just go there and ask your question there. And we already have a question from Grzegorz. So the question is, can greater expectations be used for data monitoring?
Yes, that's a good question. because I didn't test that. But I know that you have a statistical test to test distributions in Great Expectations, but I didn't test that.
Okay. And so we can use Great Expectations for setting some expectations, right? And then so this is like the main how to say, the main usage, the main thing like behind this tool, right? And then
Yes.
it can do some other things on top of that. Okay.
I mean, it's in reality, I showed an expectation on one column, but you can also do an expectation with two columns, for instance, with different also data sets. And this way you can check your two distributions, for instance.
Okay. Another question about Great Expectations. Do you know if it can handle large data or it can handle streaming data?
Yes. Okay. Yes, it can handle large data when you're doing expectations because below you have Spark. I mean, it depends, but you can decide to use Great Expectations with Spark. But personally, I had difficulties to use it to do profiling because you can. It's not always easy to know in advance what you want to test. So you can say to Great Expectations, profile my data and tell me what is the best as expectations. And to do that, I had difficulties to handle that with large volume. And the way at the end to do that was to use a sample.
Oh, that's cool. So you can just say, here's my sample, give me some asserts, some checks, and then you look at these checks that the tool provided, and then you see if these expectations make sense. And if they do, you keep them, right? Or you adjust them.
Yes, exactly. And you can also decide to save it and use it directly. It depends.
Okay. What about streaming? Does it work with streaming data?
I don't know.
You haven't tested it.
No, I think so, but I don't know.
Yeah, so I know it works with Spark. What other tools does it work with?
Pandas.
Pandas, okay. Because in Spark we can also have some streaming, also like mini batch streaming. Yeah, maybe it also can play with, can work with that. Okay. So there is a question about notebooks, if you can share them.
Okay, of course. I can
Okay.
share them.
Maybe after the talk, maybe we can just put them to the description. It's like it
Yes.
was 3 or 4 notebooks.
Which one?
Like I think that it's plural, like probably all the notebooks. But we
Okay.
can do this after the talk. So if you can send me the links, I'll put them in the description.
Oh,
And
okay. Okay, I
yeah,
will do that. Okay.
yeah. Okay. The question is, what tooling would you use for versioning data models metrics if you are going to build everything custom, not to be locked to a particular vendor?
I think, I'm not sure, but I think the question is related to ML flow.
So maybe if I can share the screen so you can see.
Maybe. Just.
So you see what the question is. Maybe it's easier
Yes,
for you.
okay. Perfect. What tooling would you use for versioning data model metrics if going to build everything custom? Okay.
Because Databricks is sort of you can get some sort of vendor lock-in if you use Databricks, right? Even though it's open source, or not really.
I don't know. I don't think so because it's open source. But I have a colleague of mine who decided to do an ML flow, a custom LML flow without the UI, for instance. So I think that you can find other solutions. But I think in my case, I will use MLflow anyway, because I'm used to that, first of all. And you can use it outside of Databricks.
Mm-hmm. Yes, the Databricks will also use MLflow, and it is outside of Databricks. So we set it up ourselves. So we use AWS, we just set it up in AWS, and different teams use it.
Mm.
Okay, so yeah, we have another question. Can you explain about Databricks and the cost? Do you use it instead of Jupyter?
Yes. Yes. Okay, I don't use Jupyter at all, only for small tests sometimes, but that's all. What I use is a mix of notebooks and, well, if I can say, Python scripts, because you can also do that for Databricks. And Databricks, I would say it's a platform to do machine learning. In reality, you also have TensorFlow behind, or scikit-learn, not only Spark, and you have a lot of tools around that. What it costs? Good question. It depends on the machine you use. And I think it also depends on the cloud provider you use.
Okay. So basically, if you have a lot of data, it can be costly. If you don't have a lot of data, it's okay. Like with pretty much everything else, right?
Yes.
Okay. Okay. Yeah. While we are waiting for more questions, maybe I wanted to ask you some stuff as well. So you mentioned that you were telling a story about data versioning, and you said it was about drift monitoring, like about setting expectations about data and unit testing data. So you said you received data, and there were a lot of bugs in this data. So I like this. I like this expression. So I didn't previously hear about, like, usually when we talk about bugs, we mean bugs in the code. And it's the first time I hear that somebody says bugs in data. So I'm really curious, what kind of bugs did you have there? Maybe like what kind of problems were in this data with this data set? Do you remember?
Yes, I remember. It was very basic bugs, if I can say. For instance, you have an ID which is supposed to be of length 10, but you receive something of length 5, and you have no idea why. So yes, it was bugs like that, but we received a lot of bugs like that.
How do you even know if it's a bug? Like in this case, when something like instead of a long ID, you started to receive short ID. Well, I guess it's a good idea to have an alert about this, to know, okay, something strange happened, right? And then you talk to a team, or like how does it usually work?
Yes. When we received something like that, we talked to the team to understand what happened, and we were sure it was a bug because these IDs correspond to something in reality. Finally, it's like a code in your box, in your web box. So we knew that it was wrong. In this case, it was easy to know, but sometimes it's not easy to know that you have a bug in your data.
Okay, we have more questions. So I'll just make it easier. I'll share the screen with you. Can you explain on the profiling tools you used in your projects, both with machine learning and latency, throughput, hardware accelerators?
The profiling tools.
Yeah, so I think you mentioned that you used great expectations for profiling to understand what the data looks like, right? Maybe you use some other profiling tools for.
Yes, in database we have a lot of information about our jobs. We also use Spark. I'm a Spark developer mostly. So that means that we have a lot of information in the Spark UI, for instance. So finally, everything is already included
Mm-hmm.
in the platform we use.
I'm also wondering what kind of profiling tools there could be for machine learning. So this is, I guess, a model like drift detection and things like this, right? Like if you think about this, or I'm just wondering what kind of tools we actually can, what we can do to profile machine learning models. That's an interesting question. Okay, so do you suggest data scientists to use these ideas of versioning and monitoring when making models, or it should be used by the engineers?
I think it is worthwhile for data scientists to also use these ideas of versioning or monitoring, because even when you are doing some experiments to reach the best model ever, I think it's valuable to have all the experiments you did before choosing the best one.
Yeah, like basically tracking all your experiments with some sort of experiment tracker tool like ML4, right? What about data versioning? Like when you, as a data scientist, develop your model, do you need to worry about data versioning as well?
That's a good question. I don't know, because it depends on your role as a data scientist, of course. But during data exploration, I'm not sure if you use always the same data, maybe it's useless. But if you receive different data, maybe it can be useful to understand the differences that you can receive between two kinds of data.
And I guess it also depends on the stage of your project. So if it's just getting started, if it's just the first iteration, the first prototype, maybe you don't really need data versioning. But when it's already deployed, it's already like production, then you need to start worrying about these things, right?
Yes, I agree.
Okay. So, and it's a good to have an engineer nearby who can help to set this up, right?
Sure.
Okay. Yeah. Oh, there is one more question. So I was too early to stop sharing. So yeah, how do you link a particular version of the model with a particular version of data? That's a nice one.
Yes, that's a nice one. At the beginning, I did nothing, just using the timestamp, because you have the timestamp when you train a new model, and with that, I was traveling through the data. But then someone from Databricks told me to store the data version, the number of the data version, and yes, it's easier. So in MLflow, you can log everything you want, and you can also log the version of the data to retrieve that after.
Ah, that's nice. Yeah, okay. So you basically, so in data lake, Delta Lake, you have some sort of identifier of the current version of data, right? So you
Yes.
can take this and you can put in your, when you log experiments with MLflow, you just put this there and it's stored in MLflow. Oh,
Yes.
that's nice.
Yes.
Okay.
It's possible to do that.
Yeah, I'm curious. Have you tried any other data versioning tools apart from
No, I have seen some demos about GVC, but I have never tested.
So I know there is the DVC, there is Pachyderm, there's
Yes, true.
also Lake of Us, I think. Yeah, I'm curious if would be curious to see a comparison of all of them.
I would be curious too.
Yeah, okay. Well, I guess yeah, so there is a comment from Mikhail. Yeah. So the comment is ideally data should be delivered solely from the model without external database like ML4. But I guess you can log it uh, in some other way, not just ML4. But in my experience, having like external database like ML flow is useful. even if it's not MLflow, but even if it's just a spreadsheet, Excel spreadsheet, like a place where you store this stuff about the model. I think it's useful. Okay, so I guess we should be wrapping up. I want to thank you for joining us today, for sharing your experience with us, for showing us all these tools, and for answering questions. And I would like to thank everyone else for joining and watching the talk and asking questions. So thanks.
Thank you very much. It was a pleasure.
Yes, thanks. And yeah, goodbye, everyone. And